Okay, build tight, ventilate right. I want you to know that the Canadians have been taking credit for this phrase, but we stole it from a Swedish guy. Just letting you know. I forget his name. Anyway, so what's tight, what's right? And so the short answer in terms of tight is get rid of the big holes so the small holes don't matter. Get rid of the big holes so the small holes don't matter. And so here are what I call air barrier metrics. I'm responsible for this table, and I want to tell you where it comes from, because you need to know where these things come from so that you can smile and say, gee, maybe I don't have to be anally fastidious on everything all the time. So I was a 27-year-old punk kid with a $10 million budget saying, define air barriers for a Canadian program called R2000. I didn't know, but I knew that I didn't know, so I asked one of my mentors, an old guy by the name of Gus Handegord, and Handegord was one of the guys that wrote the best book of all time on the subject, and he said, come on, Joe, that's stupid, you know, and blah, blah, blah. And I said, Professor, it's your damn money, you're asking for this. Go and measure the air leakage of drywall. Get 10 sheets of drywall. I got a friend of mine, Jean-Claude, J.C. Perot. He's building apartment buildings in Edmonton out of drywall as the air barrier. We'll set the air leakage of drywall as an air barrier. So I got 7 sheets of drywall and I measured it in 1982, and that's where the 0.02 liters per second per square meter at 75 pascals come from. This got adopted by the Canadian and American codes. So the air leakage of drywall defined an air barrier. Well then, you know, LEED and the GSA wanted me to deal with assemblies and enclosures, and I said, well, we should probably baseline and measure stuff. We don't have time, guess! So I multiplied the 0.02 by 10, and I got 0.2, and I multiplied that by 10, and I got 2. There was no testing. I just took 7 sheets of drywall in 82 and multiplied things by 10 and 10, and that became the codes. That's crazy. But there you go. It's got adopted by LEED. You have to convert it into, from the metric into, you know, imperial units. So the intent was always just get rid of the big holes. Now, the Army Corps of Engineers talked to me and said, well, what should we do if you know, well, you should probably baseline your buildings. And so they baselined and measured about 100 of them and then figured out that, so that's why their number is, for enclosure, is 1.25 as opposed to 2, because they did it correctly. I tried to tell GSA, well, what you should do is probably measure what you got, see what works, what doesn't work, you know, spend a year, figure this out. Joe, we don't have time, give us your best guess. I told the Army, hey, take time, figure it out. The fact that their number is 1.25 and mine was a wild ass guess at 2 makes me feel pretty good. But you shouldn't rely on a guy who's pulling a number out of his butt to change codes, right? Okay, you don't understand. This is not the way you should do things. We ended up this way because people were impatient, didn't have time, and I worry about the same things being repeated in other aspects of our business, all right? You should measure things, take a deep breath, figure it out, and have a reasonable number as opposed to just bullying your way through things.